do you remember the time when Arduino Uno was launched? Well, it was a revolutionary product both for the makers and students community because of its ease of use, and also prototyping was really very simple and shoulder free thanks to the variety of available sheets for Arduino Uno. And with this Arduino Maker series, I personally think that Arduino is going to repeat the history. So Arduino Maker series is an Arduino board with the built-in Wi-Fi and Bluetooth connectivity. So basically it's an IoT board from Arduino, and also it has a variety of shields available in the market for different projects and for different purposes. Okay, so this can be the new Arduino kit specially made for IoT development projects, and maybe this can be the next Uno revolution. Okay, so in this video I'm gonna let you know everything regarding this board, like what are its specifications, how to use it with the Arduino IDE. I'll also let you know how to use it with the Blynk IoT platform and the Arduino IDE cloud platform as well, and in the end I'll let you know what kind of different projects you can make using this particular board. So without wasting time, let's quickly start learning about the new Arduino board. This video is sponsored by LTM, which is a PCB designer software company. LTM has all the tools that you need to design a professional PCB with high productivity. And well, it is widely used in big electronic companies like Texas Instruments, Siemens, Seagate, and many more for their PCB designs. It has advanced routing features, real-time cost estimations, and also you can design your own flexible PCBs using this software. So this is an all-in-one professional PCB designing software for all your needs. So go ahead and try your hands on with this software. A free trial version is waiting for you. Now click on the link mentioned in the description to get a free trial of LTM Designer software. Starting with the box content, then this is how you'll receive this product, and on the top you'll be able to see the graphical image of the board with the branding MKR WiFi 1010, and on the back you're gonna see a couple of important specifications of this board, like what is the chip and what's the clock speed. We'll be getting into details about the specification later on. On the one of the side we get to see the authentication sticker, that's a holographic sticker of Arduino, and on the other side there's nothing much, just a branding of Arduino and Maker WiFi 1010 board. Okay, and on the top and bottom we have nothing much. Okay, so this is all about the box content, and now let's move on to the unboxing of this product. So while opening the box, the first thing that we get to see is the actual board, the Arduino WiFi Maker 1010 board, and it got the nice male-female headers, and there is also label on the side of the female headers, which is pretty helpful while making the projects using this particular board. Other than this, we get to see the manual from Arduino. So yeah, this is the manual in English language, and after that we get to see a couple of stickers of Arduino, DIY, and basically Arduino branding. Okay, so yeah, that was all about the unboxing part of the product. Now let's focus on the specifications of the board. So now let's talk about the specifications of this Arduino board. So the main heart of this Arduino board is the SAMD21 Cortex M0 Plus, which is a 32-bit low-power ARM microcontroller clocked at 48 MHz clock frequency. Along with that, it also has the u-blox Nina W102, which is an ESP32 based chip that adds the Wi-Fi and Bluetooth connectivity option to this board. But if we look at the box side, then on the connectivity it only says Wi-Fi, which is pretty confusing because on the website it says it has a Bluetooth connectivity as well. And well, as u-blox is an ESP32 based chip, so we can expect both Wi-Fi and Bluetooth connectivity option. Okay, so don't get confused. After that, we also have 256 KB of flash memory with 32 KB of SRAM, and unfortunately it doesn't have any EEPROM built in. Now talking about the pins of this board, then it contains 8 digital IO pins, 13 PWM pins, dedicated UART, SPI and I2C pins. Now talking about the analog side, then it has 7 analog input pins, 1 analog output pin, and it has 10 external interrupts. Okay, so that was all about the pin configuration of this particular board. Now talking about more small details, then it has a built-in LED which is connected to the digital pin 6. Along with that, it also has an RGB LED which is connected to the u-blox Nina module. And we also have one dedicated I2C connector using which we can connect external I2C based sensors or devices. Then this board also has the LiPo battery connector with built-in battery management circuit. That means we can charge our battery here inside this board only. So we don't need any external charging circuit. Everything is built on this board. So those were the specifications of this board, which seems pretty interesting for an entry-level IoT board, and you'll be able to make like majority of IoT projects using this particular board. So now enough about the specification, box content and unboxing part. Let's just dive deep into how to use this particular board for making our projects using Arduino IDE. Okay, so now let's start with how to use Arduino Maker 1010 board using Arduino IDE. And first of all, we need to add the boards package for this particular board, and for that we need to go to Tools, into Boards, and now into Boards Manager. Now here just type MKR and press enter, and here is that supported boards packages. In my case I already installed it. The version is 1.8.12, and in your case you may not have installed, so you need to install this board. And after installing, now we are good to go to upload our first example code onto this Arduino board. And what I'll do, I'll upload the basic Blynk sketch in this particular board, and for that I'll go to the files, into examples, then into basics, and then into Blynk. I'll maximize this, and yeah, the code will be the same. I'll select the right board and port. So board is already selected, which is selected from here, MKR WiFi 1010, and after that I'll select the port, which is this, and let's click on the upload button. So it's compiling right now, and it started uploading. It will take some time to upload the code on the board. Hey, wait, it's done uploading. It just took 0.011 second to upload my, yeah, this is lightning fast uploading onto this board. Wow, this is superb. And on the board you can see that the LED on the board, which is the orange LED, started blinking at the interval of 1 second. So we were successfully able to upload our first sketch on it, and yeah, the code uploading speed was literally impressive. Let's just try with other codes and let's see if the same speed we are getting the same speed or not. So now what I'll do, let's just test the Wi-Fi related example code, because this board is capable of Wi-Fi and Bluetooth related stuff. So I will upload some HTTP based code. Let's just search which code will be perfect for this particular thing. So I'll go to Wi-Fi Nina generic, and here inside that I will upload the, let's take an example of a web server. Okay, simple Wi-Fi web server. Let's upload this code and test out the Wi-Fi driver of, or the Wi-Fi chip of this particular Arduino board. So here's that simple Wi-Fi web server code, and this code will be turning on and off the LED based upon the button pressed onto the particular web page. And for that we need to add the SID name and password, which will be available inside the Arduino secret. So I'll add the Wi-Fi name, the SID name and password of my Wi-Fi router. And yeah, that's pretty much it. Now let's click on the upload button, and now let's just test, are we getting the same uploading speed or not. So it's right now compiling. I've never seen this kind of uploading speed. Let's say, okay, it's compiled, it started uploading, and dude, it's uploaded. It took just 0.019 seconds. Like, I'm totally impressed with the uploading speed. Can you tell me what's that one thing inside a development board which varies the uploading speed? Like, for taking example of ESP32 board, it takes a lot of time to upload the code onto the ESP32 board, and if you compare it with the Arduino, it took less than 100 milliseconds. Do you know the reason of this change in uploading speed? If you know, do let us know in the comments of the video. Now let's just test this example code. So I opened the serial monitor. It's getting connected with my Wi-Fi router. It's connected, it got its local IP address. So I'll copy the local IP address. I'll open Safari on my system. I'll paste that IP address here. Hopefully it should open the web page. Okay, the web page opened up, and here if I click on the on button, as you can see, the orange LED on the board got turned on. If I click on the off button, okay, it got turned off. So yeah, the Wi-Fi chip is also working, and we are able to control the LED, like the built-in LED of the board, using the web page. It's taking a time this time. Okay, it's turned on, it's turned off, on and off. Yeah, this is also working perfectly fine. So we successfully uploaded the example code. Now onto the website, it says we can use this, as it is an IoT board, we can use this board using Blynk, using Azure, using AWS IoT code, and of course using the Arduino IoT cloud as well. So now what I'll do is I'll let you know the most commonly used IoT platform in the makers community, which is the Blynk and the Arduino IoT cloud. I'll let you know how to use those IoT clouds on this particular Arduino maker board, so that you can start making your IoT projects as soon as you get this board in your hand. Okay, so let's just test it out. So what I'll do is I'll open up my Arduino IDE, and let's open the Blynk related example sketch. Okay, so yeah, this is the Blynk related sketch, and it's pretty much, or rather it's exactly the same as we are using in the ESP32 boards. Okay, so we just need to provide the authentication token, we need to provide the set name and password, and we need to provide the logic that we want to provide to our projects. In our case, we didn't provide anything because I just want to turn on and off the built-in LED on the board. Okay, so I didn't provide anything. And talking about the Blynk application sites, then here you can see I have prepared a Blynk project in which I have just provided an on-off button which is configured with digital pin 6, which is nothing but the built-in LED of our Arduino board. And that was the basic Blynk project. I just copied the authentication token and pasted authentication token here inside the code, and that's pretty much it about the Blynk related code. Let's try to upload this code and let's see if it works with Blynk or not. Okay, started uploading, and we don't need to skip the video because it's already uploaded. Okay, so now let's just try this example code. Let's see if it works with the Blynk or not. Okay, so as you can see, we are able to control the built-in LED on the Arduino board using our Blynk IoT platform like the previous generation of the Blynk. Okay, and yeah, it's perfectly working fine with a very less latency. So this is how you can make your Blynk related projects on this Arduino Maker board. And now we are left with how to use it using the Arduino's own cloud platform, that's the Arduino IoT cloud. Let me guide you with that as well, because that requires a couple of steps to be configured as compared to the Blynk. Okay, so I'll go to Arduino IoT cloud. Okay, and here of course you need to make an account. I have made a dedicated video on how to use the Arduino IoT cloud, so it will be better if you watch that video to know all the things about this cloud platform and how to use it in a very detailed manner. Okay, in this video I'll be covering how to use this maker board with the Arduino IoT cloud. I'll be covering that part only. Okay, so here you need to make an account of course, and after that first of all we need to add a device. So I'll go into the device section and click on add device. Now, as this is an Arduino board, we'll be selecting set up an Arduino device. Okay, now as the cloud is from Arduino and this board is also from Arduino, so they have a nice, what you can say, ecosystem in which any of the Arduino board, IoT board connected to this device will be automatically recognized by this web application. As you can see, it is already recognized as Arduino Maker Wi-Fi 1010 board. Now here one thing need to be very careful about is if it is not at all recognizing, then you must not be having this Arduino create agent on your computer. Now this is a software which is a must to use the Arduino IoT cloud web interface with your Arduino board. So if you don't have, just install this Arduino create agent and make sure it is running in the background, and it will automatically recognizing your hardware. Okay, now I'll click on the configure button. Now it's a random name. I'll change its name to MKR Maker. I'll click on the next button, and now I'll take some time to make this board get ready to be configured with the IoT cloud. So let's just fast forward this video. Okay, so it says congratulations, or you are all set. So I'll click on the done button, and as you can see, our device is added inside the device section. Now the next step is we need to configure the things. Okay, so we'll go into the things section, create a thing. Okay, and here we'll be clicking on add variable. Okay, now what we are doing is here we'll be making a small project of controlling the built-in LED using the Arduino IoT cloud dashboard. Okay, and for that I'll create a variable called as LED, and the LED type will be boolean. Okay, it's just a 2-state on and off, and I'll click on the add variable button. So we have added a variable here, and now we need to select the device, like on which device we need to add this variable. So I'll select device and select our Arduino Maker board, which is already added. Okay, I'll click on associate. So now this variable will be associated with this particular board, and last step is we need to configure the networks. That means we need to provide the SID name and password here. Okay, so I'll give my SID name and password of my Wi-Fi router, cross-checking it. Okay, the password is wrong. Great. I'll click on the save button, and we have provided pretty much every details. Okay, so now the last step is we need to prepare the sketch for this particular board, and we can add the sketch and upload it using the same IoT cloud platform only. We don't need to switch on to Arduino IDE. Okay, so here's this ready-made sketch made for our single variable LED, and whenever we provide data onto this variable, this built-in function called as onLED change will be called. Okay, so now here we need to provide the task, whatever we want to do whenever that button is pressed or not. Okay, so here first of all I'll declare a built-in LED as an output. So I'll write bin mode LED underscore built-in comma output. Okay, and in the function what I'll do is I'll write digital write, then I will be changing the state of built-in LED based upon the response that we are getting from the Arduino cloud dashboard. Okay, yeah, that's pretty much it. I'll put on the semicolon here, and this is a very basic code. And now what I'll do, I'll upload the code from this web interface only. So that's a very cool, platform developed by Arduino team. Okay, it says success, done uploading, and now we can turn on and off the LED on the Arduino board using the IoT cloud platform. But before that, we need to make a dashboard, and for that we need to click on this dashboard button, and here click on build dashboard. Now in this dashboard, we can add a couple of widgets based upon our project. Okay, in our case, it's a very simple project, so I'll quickly add the switch, and I'll configure this switch and linking it with the variable called as LED. I'll click on link variable, and we are done. Click on the done button, and our cloud dashboard is successfully configured. And now click on this I button, and now we can turn on and off the LED on the board using this switch. Let us test it out. So it's now off. Okay, and as soon as I turn it on, as you can see, the built-in orange LED got turned on. Okay, and if I turn off from the web dashboard, as you can see, it got turned off. So on and off, on and off. And the same thing we can control using the IoT cloud mobile dashboard. Here is the video. So as you can see, I'm easily able to control the LED using the IoT cloud mobile application by Arduino. So those were the commonly used IoT platforms, the Blynk and Arduino, using which you can make tons of IoT projects, and now with the help of the Arduino Maker Wi-Fi 1010 board as well. Okay, now one thing which is still missing and which is still, we can say, mysterious, you can say, which is we have a built-in RGB LED on this particular IoT board, and we don't have any code to control this particular LED, and we don't even know on which pin this LED is connected with. I tried to search a lot about how to use this built-in RGB LED, and on the forum, like on one of the forum, I found out its solution, which is like there are two steps involved to use the built-in RGB LED. First, to install the Wi-Fi Nina library, okay, because this RGB LED is connected to the what you can say U-Blocks chip and not with the SAMD21. Okay, and second step is, which is particularly need to be done for this board, it is we need to modify the library a little bit just to make it compatible with this RGB LED. Okay, so I'll guide you with all those, like all the two steps, which will be helpful to you in case you want to use the RGB LED. Okay, so first, to install the Wi-Fi Nina library, you need to go to Sketch, into Include Library, and into Manage Libraries. Here's the search for Wi-Fi Nina, and here is that library. You just need to click on the install button. It will automatically install on your computer, and after installing that, you'll still not be able to control the LED. You need to change one more thing, which is you need to change the library, and for that you need to go to the library folder of the Arduino, which is inside the documents. So yeah, here's the library, and search for Wi-Fi Nina library. Here is the Wi-Fi Nina. And here inside the source folder, we have this two file, wifi.cpp and wifi.h, which is the header file and the C++ file. Okay, I'll open both the files. Okay, so here's that file. So here in the Wi-Fi C++ library, we need to add this much line of code, and also we need to add this function, and inside the header file we need to write these many functions. Okay, so there are two steps. Either you can write manually these two things, or the second option, which is more convenient, which is I will provide both Wi-Fi CPP and Wi-Fi.h header file on my GitHub repository. So you just need to download them, and you just need to overwrite them, or you can delete these two files and paste my own Wi-Fi.h and C++ file, and that will also work. Okay, so I'll provide both the files in the GitHub repository, whose link is in the description. Okay, so after doing these configurations, now we are good to go to use the built-in RGB LED, and here I have made a sample code to use all the three LEDs. Okay, so whichever LED you want to use, you need to provide that brightness value, which is from 0 to 255. So it will turn on the red LED, after 500 milliseconds it will turn on the green LED, and after 500 milliseconds it will turn on the blue LED. Let's just try to upload this code, and let's see if we are able to use this RGB LED or not. Let's click on the upload button. Okay, it's done uploading, and as you can see, the RGB LED on the board is working as per the code that we have written on the Arduino IDE. Okay, so yeah, these were some of the steps that you need to perform to use the RGB LED, and yeah, that was all about how to use this board using Arduino IDE, using Blynk IoT platform, using the Arduino IoT cloud platform as well. So yeah, here we come to the end of the video. So we discussed everything regarding this board, starting from the box content to how to use this board for making your IoT projects. Okay, so now let's discuss in detail about what kind of projects you can make using this board. So well, Arduino brands this board as an entry-level IoT board, and if you are using it as an entry-level IoT board, you can make all the basic plus advanced level projects using this particular board. Maybe your home automation project, maybe your like Wi-Fi or Bluetooth based home automation project, anything you can make using it. You can make RFID based control system, you can make all the electronics and IoT projects. I think it's possible to be made using this particular board. So you can definitely try out this board, and also you can try out different shields to make your prototyping way more easier and shoulder free. I'll leave the link of this board as well as the shields down in the description of this video. Okay, so now my reason of making the video on this particular board is I received one of the kit based on this Arduino maker board, which is the Arduino OPLA kit. Okay, so this is a kit which has a couple of sensors, and the heart of this kit is this Arduino maker board. And soon I'll be making the unboxing and getting started video of this particular kit as well. So make sure you subscribe the channel in case you don't want to miss out like how's the kit all about and what kind of projects you can make using that kit. Okay, I'll soon be making the video for that as well. Okay, and yeah, that's pretty much it. I hope you enjoyed the video. It was pretty long, I know, but it was a detailed guide as well. Do let me know your review, your feedback down in the comments of the video. Like, was this video worth watching or not? Do let me know your valuable suggestions, reviews down in the comment section of this video. And that being said, I'm just ending this video here, and now just wait for my next video. Explore, learn, share with me, techiesms.